Welcome to ASOC Tutorials India program, a platform to learn amateur radio in India. So, I am continuing to my previous sessions on semiconductor. It is opto-electronics, or in simple words you can say optical semiconductors. So, this name is something new, optical semiconductor, for some student, but it is very important. Why? If you see your surroundings, you may find so many gadgets, electronic gadgets. They are using semiconductors in various forms. Example, mobile phone in your hands have LCD screen or AMOLED screen or IPS screen, and also a camera which is recording your photos, and same time you have a remote controls in your hand, changing channels of televisions or controlling air conditions. And don't forget, nowadays internet coming to use also in optical fibers. So they are using lights. The light is similar to wavelength. There is a minor difference, but remember, semiconductor is not sold an individual device or component in the market, but that is used in devices, in so many appliances, electronics. You may think about car, think about anything, fridge everywhere, temperature controller, so many sensors, night vision camera, and internet of the things, IoTs, M2M, machine to machine, device to device, everything is being connected here. Maybe smart city, maybe quantum computing or supercomputing, everywhere you will find semiconductor. And today I am continuing with semiconductor, optical semiconductor. This is a level where instead of waveform as a waves, a light is being used. So first question coming itself, what is optical semiconductor itself? The semiconductor is a material where the electronics band structure exhibit the relatively small band gap between the valence and conduction band. If you are confused, go through semiconductor part 1. It is already very much explained there with the table. So different kinds of semiconductors are relevant to optics or photonics. So single element group 4, you have seen that table in semiconductor 1. They are semiconductors like silicon and germanium. They are subject to limitations due to their indirect band gap. Or on the other hand, silicon is attractive for opto-electronics because of its wide use of electronics and highly developed fabrication processing technology, and it is easily available in the earth. So compound semiconductor also there, part 3 and 5. Remember, I have explained you in intrinsic and extrinsic semiconductor, also trivalent and pentavalent impurities, also how we are adding, how we are making use of them. And gallium arsenide and indium phosphorus, they are some which we can use them, not going in details. So in 2 or 6 also some are there, Hg1 and other, not going into detail, but they are very much used because semiconductor properties and applications, they are very much depend on valence band, use doping level, and use material and other parameters including temperature. On based on different kind of combination mixture, we are using different kind of applications. So these are some organic semiconductor which are used in organic photonics, but these are very much less developed, but somewhere in special application they are used. So coming to the next, what is optical property? First of all, this kind of semiconductor has some optical property. They have band gap energies of semiconductor, which is just I'm going in further slides so that you can understand. So somewhat longer wavelength. Wavelength is a parameter which is defined for our radio frequency, and say wavelength is going in narrow, even nano level. Then in mid, some infrared lights are coming. They can exhibit in property. Low propagation losses are there, but they are very useful. And they are, some are gallium, indium, arsenide. Already you have used in intrinsic semiconductor, and some nearby also we can use them. So they are obtained in similarly wide or even wider transmission windows. As for dielectrics, only a reason of longer wavelengths are used, and the reflective index of lights or opticals are relatively high, larger than a typical dielectric, often in order of 3. Not going in detail because this is not required in ASOC exam, but engineering student, BTech student know about it. The phase velocity and group velocity are corresponding low, and chromatic depression is strong here. Now you see in this image, it is very important to understand. First of all, light. This light itself is classified the same category as X-ray used in hospital, and even electrical waves used in television, mobile phone, radio, FM radio, even communication system, and other walkie-talkies, etc. They are all electromagnetic waves, EM wave. So first, up to 3 meter band, I can say around somewhere 100 megahertz, they are radio waves used. Of course, higher also used, but they have different applications. Even mobile using 900 megahertz, 1800 megahertz, 2100 megahertz, etc. But they are coming in microwave range. They are slightly higher. So microwave also used in communication, but slightly go more above. So this bandwidth will go more narrower in nanometers, 900 nanometer. So this one nearby infrared rays will come. Infrared rays you can't see, but we are using in devices. So but just 900 nm, after that visible rays start, which you can see. Don't forget your LED lights giving lights, your remote control in DTH also showing lights, and so many disco lights are coming in your TV studio system, and so many applications, even in adapter also. First, this visible rays start from 700 nanometers, starting with a deep red color, slowly it go to the orange, yellow, green, blue, purple, etc. Remember with cure. This is a sequence. So this is somewhere ending around 420 nanometers, but still it goes. So after that, the rays start from ultraviolet rays, X, gamma, and continue. But my intention of today is only visible rays, because this visible rays is only used for light communication, and this is called optical in optical waves. So this light and electric waves, the main reason behind is wavelength, lambda equal to c by f. Already explained you. So going to the next. Now the optical semiconductor, or I can say light emitting elements, have a minutely detailed structure that allow them to convert electricity into light or light into electricity, or I can say vice versa. So LED you have seen in lightning, traffic light everywhere displayed, backlight everywhere you can see, these are LED lights. And laser diode, they are used in writing of DVD, optical fiber communication, 3D sensors, etc. And infrared LED means LED is here, but you can't see because our eyes have a limitation, using TV remotes, AC remote, security cameras, vehicle cameras, and so many applications. So optical semiconductor, light receiving elements that convert light into electric energy. They are reverse of previous one. So photodiode, camera exposure meter, optical communication system, spectroscope, night vision devices, it is used. So photodiodes are reverse of LED. They are receiving and converting light into electricity. Same way phototransistor. Diode means PN junction, transistor means PNP junction, pi junction. They have also wide range of application, automatic doors, camera, smartphone, photoelectric sensor, etc. So going continuously, the main material used are already explained several times to you, gallium arsenide, GaAs. This is widely used in FET, field effect transistor. This FET already explained in previous session, FET and MOSFET, and integrated circuit, IC. It is combination, very large scale integrations of semiconductors with high electron mobility, So there are some component used for optical semiconductor, and this can go very fast up to 200 gigahertz. Of course, technology is developing, changes are coming soon, but initially I can say 200 gigahertz. So silicon germanium, it is combination of silicon as well as germanium. So both can work together and can be used as material in ICs, integrated circuit, and heterojunction bipolar junction transistor. I had given you base idea of bipolar junction transistor, but I can't go in so much depth. Even in diode, I have more than 30 type of diodes. But for you, some are sufficient to go through that one only. That is sufficient. And this heterojunction bipolar transistor, or I can say strain inducing layer for CMOS transistor. CMOS means already matter of such semiconductor told you. So not going in details, just for your ideas only, because your topic is to get past the ASOC exam. For ASOC exam, it is slightly higher. So this one you have to learn. So this transistor into lower current and higher frequency, there is application, and so because we can produce so many junctions, small chip, so it is widely used for making ICs, even microprocessors. So because it's going in high volume, the cost is coming down. So this one is very much used. So optical semiconductor is divided into two major groups. Just recap it. First, luminescent devices, which are light emitting diode, laser diode, which are creating lights, and other light receiving diode, which are receiving lights. They are converting light into energy, electricity, like solar cells and photodetector. This is continued the previous slide, already I had told you. So if you see this table on your screen, these are some of the example at what wavelength which color is mostly coming there approximately, or I can say 395 to 410 nanometer. This this wavelength is, we can say, ultraviolet, and so on, near infrared 850. So these are some visible lights spectrum. So continue, because examiner can ask question and questions are coming on some other parameter. So I am explaining you some terms. Semiconductor optical amplifier, SO, is a semiconductor element that amplifies lights or optical signals. So entire reflective process is applied on both facets of semiconductor laser to eliminate the resonator structure. When light enters from outside the semiconductor, and light is amplified by and stimulated emissions. This is SOA. Same way EDFA, erbium doped fiber amplifier. This is also one of the kind amplifier to amplify lights. And this optical amplifier used in the C band and L band, very high frequency, where loss of telecom optical fiber become lowest in the entire optical telecommunication wavelength band. And this EFDA is now most commonly used to compensate the loss of optical fiber in long distance optical communication. Don't forget, nowadays internet is also coming from optical fiber, and these optical fibers are using EDFA amplifiers. And this EDFA amplifier has another important characteristic, that it can amplify multiple optical signals simultaneously, multiplexer. So many signals are coming and all they are amplifying. So, but SO is a single, but this ESDM is multiple, combined. It can combine with wide division multiplexing technology. So going next, Raman fiber amplifier. This is less used, but this is based on Raman effect, scattering coloring code, scattering this opticals, how it is amplifying when the lights are scattering. So this is working for non-linear region, and others are on linear region. So this is also very important to understand to you. This is Raman fiber amplifier, and going continuously, not going in details. Brilliant fiber amplifier. This is also very much used. The gain and noise characteristic of a fiber billion amplifier are studied experimentally and analyzed using a displaced shifted fiber. The optimal condition of gain and on-off ratio are identical for slow light generation. This is the difference. This one is better for slow light generation at slightly lower side of lights or amplifications. So this help in bidirectional coherent application of weak signal. This coherent term is coming to you. Remember this one also very important. I am going to explain in further slide. What is coherent amplifier? So this one is very good for non-linear amplification again that can provide high gain. Others for linears. The limitation of the spectrum bandwidth is 50 megahertz bandwidth only, means lower side, or low speed communication, or I can say end user side, where the users, end user consumers are there, not the industry side, where they are giving so many connections or using high range communications. So this fiber amplifiers type is perceived to be have a rather restricted range of very less range of application. So just coming a recap, wireless remote control for product like TVs and air conditioner transmit and receive information using infrared rays. CD or DVD disc players or recorders have optical media are used to write and reading on the storage medium by lights in the form of lights and bits. An electrical equipment using light in the way above is in everywhere you go out on the road, everywhere you will find light. So they are using various forms, and without optical semiconductor I don't think you can go continuously. Now it is live. But one term is very important, laser. You know laser, but I have seen several students don't know the full form of laser. This full form laser is the light amplification by the stimulated emission of radiation. Note down this one, ASOC exam can ask full form of laser. So what is laser? Not going in detail, but something I have to tell you. This is coherent communication. They are based on external cavity design. What is coherent? Coherent system is that the receiver needs the phase information of the transmitter, the carrier phase, to recover the transmitted data at receiver's side. In non-coherent system, the receiver do not need the phase information of the transmitter carrier to receive the signal. Why? In many radar and such kind of communication received signal have very low SNR, signal to noise ratio, due to the weakening of the signal from the propagation losses, scattering, it happening in the presence of various noise sources in ionosphere. So this one is very much required to understand. So many devices needed, not going in detail, because this EML, electromagnetic laser, etc., will not going to ask ASOC exam. So I am also not going to consume my energy on it, because my topic was to give you basic concept of optical semiconductor, and I hope this one is enough to you, and even this optical semiconductor continue, but I am saying over to my topic, because now I have to go to amplifier. And before I go to next stage, some questions from you. First, for linear as well as non-linear mode, which are the most important network elements? Option: optical amplifier, optical detector, analog digital converter, DA converter. Time is limited, go fast. Yeah, optical amplifier. This is the answer. So our explanation already given on your screen. You can pause it and read it. Going to the next question. Digest is used primarily for channel selection in a wavelength division multiplier WDM system. Which one? A, B, C, D. You have a limited time. Yeah, billion fiber amplifier. This is the answer. Explanation given on your screen. I hope today's session is very useful for you. Next session I am going to cover on amplifier. So till that time, thank you very much. Hope to see you again. Bye bye. If you like it, kindly subscribe to my channel. There is a typo error, I have not updated, but I am going to update my next session on amplifier. Have a nice day, have a nice holidays, bye bye, good day.